Good morning, students. Welcome to 11th Standard Chemistry video class. We are discussing Lesson 2 Quantum Mechanical Model of Atom. In our last video, we completed the topic Electronic Configuration of Atoms. In this video, we will start with the next topic Stability of half-filled and completely filled orbitals. Stability of half-filled and completely filled orbitals. The exactly half-filled and completely filled orbitals have greater stability than other partially filled configurations in degenerate orbitals. Already we discussed that the half-filled configuration and the completely filled configuration have greater stability than partially filled configurations in degenerate orbitals. This can be explained on the basis of symmetry and exchange energy. For example, chromium has the electronic configuration of stable electronic configuration of argon 3d5 4s1 and not the stable electronic configuration of argon 3d4 4s2 due to the symmetrical distribution and exchange energies of d electron. For chromium, the expected configuration is stable electronic configuration of argon 3d4 4s2. The actual configuration is the stable electronic configuration of argon 3d5 4s1. The actual configuration is due to the symmetrical distribution and exchange energies of d electron. Here 3d orbital with symmetrical distribution and 4s orbital with symmetrical distribution. It is explained in this paragraph. Now let me discuss the symmetrical distribution of electron. Symmetry leads to stability. The half-filled and fully filled configurations have symmetrical distribution of electrons, which is shown here. Here, half-filled and fully filled configuration have symmetrical distribution, which is more stable than unsymmetrical distribution. Or otherwise, the half-filled and fully filled configurations have greater stability than partially filled configuration. It is explained here. Here, p orbital with p3 and p6 configurations. p3 with half-filled configuration, p6 with completely filled configuration. Hence, these two are having symmetrical distribution. Hence, half-filled and completely filled configurations are more stable than partially filled configuration. It is explained for p orbital. Next, let me discuss d orbital. Here, d orbital with d5 and d10 configurations. d5 with half-filled configuration, d10 with completely filled configuration. Hence, these two orbitals are having symmetrical distribution. Hence, half-filled and completely filled configurations are more stable than partially filled configuration. It is explained for d orbital. Next, let me discuss for f orbital. Here, f orbital with f7 and f14 configurations. f7 with half-filled configuration, f14 with completely filled configuration. Hence, these two orbitals are having symmetrical distribution. Hence, half-filled and completely filled configurations are more stable than partially filled configuration. It is explained for f orbitals. Consider p orbital. The degenerate orbitals such as px, py and pz have equal energies and their orientation in space are different. Again I repeat, px, py and pz have equal energies and their orientation in space are different, which is shown in the picture. Due to this symmetrical distribution, the shielding of one electron on the other is relatively small, and hence the electrons are attracted more strongly by the nucleus and it increases the stability. Again, I repeat, due to this symmetrical distribution, the shielding of one electron on the other is relatively small, and hence the electrons are attracted more strongly by the nucleus and it increases the stability. Here, the px, py and pz have equal energies and their orientation in space are different. Here, in px orbital, the electrons are oriented along the x-axis. In py orbital, the electrons are oriented along the y-axis. And in pz orbital, the electrons are oriented along the z-axis. Again, I repeat, the degenerate orbitals such as px, py and pz have equal energies and their orientation in space are different. It is explained here. Next topic, exchange energy. If two or more electrons with the same spin are present in degenerate orbitals, there is a possibility for exchanging their position. If the degenerate orbital which contains two or more electrons with the same spin, there is a possibility for exchanging their position. During exchange process, the energy is released and the released energy is called exchange energy. So here we are having the definition for exchange energy. The energy released during the exchange of electrons in the degenerate orbital is said to be exchange energy. It is an important question. If they ask what is exchange energy, you have to give this answer. If more number of exchanges are possible, more exchange energy is released. If more number of exchanges are possible, then more amount of exchange energy is released. More number of exchanges are possible only in case of half-filled and fully filled configurations. Hence, if this orbitals contains half-filled and fully filled configuration, there should be more number of exchanges are possible. Hence, more exchange energy is released. It is explained in this paragraph. It is explained with an example. Let us consider the following example. In chromium, the electronic configuration is stable electronic configuration of argon 3d5 4s1. The 3d orbital is half-filled and there are 10 possible exchanges which is shown here. 4 exchanges are possible when first electron is get exchanged. 3 exchanges are possible when second electron is get exchanged. 2 exchanges are possible when third electron is get exchanged. 1 exchange is possible when fourth electron is get exchanged. Therefore, overall electron exchanges are given by 4 plus 3 plus 2 plus 1, which is equal to 10. For 3d5 configuration, there are 10 possible exchanges. It is explained here. On the other hand, only 6 exchanges are possible for the stable electronic configuration of argon 3d4 4s2 configuration, which is shown here. 3 exchanges are possible when first electron is get exchanged. 2 exchanges are possible when second electron is get exchanged. One exchange is possible when third electron is get exchanged. Therefore, the overall electron exchanges are given by 3 plus 2 plus 1, which is equal to 6. For 3d4 configuration, there are 6 possible exchanges. Here, for 3d5 configuration, there are 5 unpaired electrons. For 3d4 configuration, there are 4 unpaired electrons. Therefore, for 3d5 configuration, 10 exchanges are possible. For 3d4 configuration, only 6 exchanges are possible. Here, more exchange energy is released for 3d5 configuration than 3d4 configuration. Hence, greater the exchange possible, greater will be the exchange energy. Hence, we completed the topic exchange energy. Also, we completed the lesson 2 quantum mechanical model of atom. In our next video, we will start with the new lesson. Thank you.